Hello friends, in today's video we will discuss about the formation of one code word FEC block from the OTN frame structure. So here we will discuss about one code word formation, that is FEC block. So what is the FEC block? The one code word is also known as the FEC block. You can see here this is the OTN frame structure. In OTN frame structure you can see here this is the column. You can see here this is the CR, this is the column and this is the row. So in OTN frame structure, you also know that there is 4080 column and 1234, four number of row. Column number 1 to column number 16 is reserved for the overheads. Column number 17 to column number 3824, total 3808 column is reserved for the payload of client area. And column number 3825 to column number 4080, 256 column is fixed for the FEC area. So I have mentioned here also 1 to 16 column, column number 1 to column number 16, that is total number of 16 column is reserved for the overhead. Column number 17 to column number 3824, you can see here 17 to 384, total 3808 column is fixed for the payload. And column number 3825 to column number 4080, total 256 column is fixed for the FEC. So let's see how the FEC block is formed by using this OTN frame structure. The 16 by 16 I will explain soon what the meaning of this 16 by 16, 16 by 1, 3808 by 16, 380 by 238. So when we divide 3808 by 16, it will give 238, and when 3808 is divided by 238, it will provide 16. 256 divided by 16 is equal to 16. 256 divided by 16 is equal to 16. I will explain soon the meaning of these terms, why I have kept this. So there will be 16 code words from each row of the OTN frame. So you can see here this is 1, 2, 3, 4. There are 4 OTN frame row for the OTN frame. So for 1, in first row you can see there are 4080 column, or you can say 4080 byte. So from each row there will be 16 code word. And how much byte in each code word? We can get it by 4080 divided by 255 is equal to 16. So 16 is equal to total code word. So if we divide 4080 by 16, we will get 255. It means in each code word there will be 255 bytes. In the same way, if we divide 4080 by 255, it means it will provide 16. Means from 4080 column or 4080 byte, we can create 16 code word, in which in each code word there will be 255 byte. So this is the first FEC block. This is the 1 byte is from the overhead in first FEC block. So in first row there will be 16 FEC block. So we are talking about the first FEC block. So in first FEC block, the first byte is from the overhead, the 238 byte is from the payload, and 16 byte is from the FEC. In the same way, the second FEC block, 1 byte is from the overhead, 238 byte is from the payload area, and 16 byte is from the FEC area. In the same way, third FEC block also 1 byte of overhead, 238 byte is from the payload, and 16 byte is from the FEC. If you add these all, 238 plus 16 plus 1, you will get 255. Means each FEC block contains 255 bytes. Same way in the fourth block and in the 15. So from first row we can create 16. You can see here. From the first row we can create 16 FEC block, and each FEC block contains 1 byte of overhead, 238 byte of payload, and 16 byte of FEC, total 255 bytes each. And if we add 255 into 16, it will get 4080 bytes. So it's very clear that from each row 16 FEC block will be created. From the first row, from the second, in the same way from the second row also the 16 FEC block can be created. From the third and fourth row also the 16 FEC block can be created. So now the question is why I have mentioned this. So 16 by 16 is equal to 1. It means here 16 by 16 is equal to 1. It means if we are using, if we are creating 16 FEC block, so how many byte in each FEC block from this overhead? This will get by this. If you divide 16, there are total 16 byte in the, you can see here, there are total 16 byte in first row of the OTN frame structure, and there are 16 FEC block will be created. So how many byte in each FEC block is used from this overhead? You can get this 16 by 16 is equal to 1. In the same way, in 3808 column, so 3 in the first row, you can see here, in first row in payload area, there are 3808 byte, and if we are creating 16 FEC block, so 238 byte in each FEC block from this payload area. So we will get 238. So you can see here 238 byte in each FEC block is from the payload area. In the same way, 256 byte is fixed for the FEC area. So if we divided 256 by 16, and this 16 is the number of FEC area from each row, so you will get 16, means 16 byte is used in each FEC block from the FEC area. In the same way, if we divided 16 divided by 1, means if 1 byte is using in each FEC block from the overhead area, so you can create 16 FEC block. In the same way, if you are using 238 byte from payload area for each FEC block, you can create 16 FEC block. In the same way, this. So this is the reverse calculation. So by this formula, you can get how many byte in each FEC block, and if 1 byte is using from each area like overhead, and 238 from payload, and 256 16 from the FEC area, then how many FEC block can be created? So this is about the FEC block formation. Let's see the position of the first byte, second byte, third byte, all in first FEC block. So you can see here one code word FEC block formation, first byte, OTN frame, audio overhead byte position in FEC block. So you can see here, this is the overhead area. You can see this is only the overhead area. Column number 1 to column number 16. There are 16 byte. Column number 1 to column number 16. 1, 2, 3, 4. 1 to 16 column for the overhead. So you know that from each OTN frame structure, we can create 16 FEC block. So in first FEC block, 1 byte is used from the overhead. So what will be the position of these overhead byte in 16 FEC block? We will discuss in this. So you can see here FEC block, 1 byte is from the overhead area, 230 byte is from the payload area, and 16 byte is from the FEC area. So we'll concentrate on this 1 byte of overhead from the overhead area. So what will be the position? You can see here 1 byte is from the overhead. So we are selecting here first FEC block. So first FEC block, in first FEC block, 1 byte is from the overhead. In first FEC block, 1 byte of overhead is taken from the here 1 1. You can see this is the byte position. So in the same way, second FEC block, and in the same way there will be 16 FEC block, and all 16 FEC block, first byte is from the overhead. So in first FEC block, the position of 1 byte is this. Second FEC block, what will be the position and which byte from the overhead area? This byte 2 1. You can see 2 1. In the same way, in third FEC block, which byte from the overhead byte is used? This 3 1. In the same way, fourth FEC block, fifth, sixth FEC block, and you can say the 15 FEC block, 15th FEC block, the first position, or you can say which byte is from the overhead? This 15 1. This byte will be from the overhead. And in the 16th FEC block, you can see the 16 1. So in next slide, we will discuss about position of 233 bytes of payload in the same 16 block. Here you can see first byte of FEC. So here we will see one code word FEC block formation. 238 byte means this 238 byte is taken from the payload area. So what will be the position of that byte and which byte is taken in which FEC block, first FEC block, second FEC block. We will discuss it in detail in this. So you can see here, I have mentioned here only the payload area part, 17, column number 17 to column number 3824, column number 17 to column number 3824. So they are total 3808 column, and that is for the payload. So if you divide it into 3808 divided by 16, you will get 238. That's why I have mentioned I have created the group of first 16 byte, second 16 byte, third 16 byte, 238 16 byte, and 238 16 byte. So in first row, if you're talking about the payload area only, so there will be total 3808 byte. So I have divided into 3808 into group of 238, and in each group there is 16 byte. So first 16 byte will consider 16 byte, second 16 byte is also consist 16 byte. In the same way 238 group is also consist 16 byte. So let's see. This is the FEC block. In FEC block, you also know that this FEC block length is 255 byte. 1 byte is from the overhead, 16 byte is from the FEC, and 238 byte is from the payload. So I have already discussed this one. We will concentrate on this 238 byte of payload. So you can see here in FEC block, this is the position 238 byte is taken from the FEC block. So I have mentioned this part only. So in first block, second, third, in the same way like 16th FEC block. So in first FEC block, there will be 238 byte from the payload area. So which will be the first byte in these 238 byte? So first byte is from this first 16 byte group, and that will be 16.1. In the same way, this second byte is placed in the first group of 16 byte. The second byte is placed in second FEC block, first byte. In the same way, third FEC block, in the third FEC block, the first byte is taken from this group, third byte. And in the same way, 15th FEC block, in 15th FEC block, first byte is from payload is taken from this first group of 16 byte, and that is 31.1. And in the same way, the last byte of this group is taken from here and it is placed in 16th FEC block, first byte. So you can see here in first FEC block 238 byte will be there. So in the same way, what will be the second byte of first FEC block? The second byte of first FEC block is taken from the second group of 16 byte. You can see here that it will be 331. In the same way, in the second FEC block, second FEC byte is taken from the second 16 group and that will be placed here. So in the same way, third byte from this group is taken from here. And in the same way, you can see this 47.1 is placed here and 48 placed here. In the same way, this 13 16 byte, 13 16 byte of group is placed here. Just this, you can place this, you can place this horizontal to the vertical. Just put this horizontal group of 16 byte in vertical form, and you will get the position of bytes. So in the same way, 3, 4, 5th, 6th, and so on will be gone. So you can see here in the last 236 group of 16 byte is placed here, 3793 byte is placed here, 37941 byte is placed here, 3807 is placed here, and last byte of this group is placed here. I have just put the byte name. It is not a particular, it's not a standard. I have just put the name of this byte just for the understanding. In the same way, the last group of 16 byte is placed in the, you can see here, last byte of FEC blocks. So this is like byte is selected from this payload area and create the FEC block. So you can see here what you can notice one point here, that in first FEC block, the 238 byte is not taking continuously. It is just break into some blocks. Like first byte is taken, say 16 byte is taken continuously. Then in second byte, This second byte is taken, and in third byte, after third byte is taken from the third group, fourth byte is taken from the fourth group, like that. In the same second FEC block, the first byte is taken from the first group of 16 bytes, second byte is taken from the second byte of 16 byte group, third byte is taken from the third byte of group. So that what is the benefit of this? So major benefit of this is that it can crack the burst errors. And burst error or continuous error can be divided into different FEC block, and this is the major advantage of FEC. Using FEC in OTN frame structure means continuous errors can be break into burst errors. So let's see for the 16 byte of FEC. So one code word, in one code word formation, what will be the position of 16 byte of the that is taken from the this FEC area? This is a 16 byte of FEC. So you can see here, if we divided 256 divided by 16, it will give us the number 16. Means there will be total 16 group of 16 bytes for the 16 FEC block. So this is the first group of 16 byte. This is the second group of 16 byte. This is the third group of 16 byte. In the same way, 15th and 16th group of FEC byte. So in first FEC, in first group of FEC byte, there are total 16 byte, and that 16 byte is placed one by one in FEC blocks. So we are taking, so you can see here in first FEC block, there will be total 16 bytes here. One byte, second byte, third, fourth, 15, 16. So the first byte position is taken from the first group. Second byte is taken from the second group. Third byte is taken from the third group. In the same way, the 15th byte is taken from the 15th group, and the 16th byte is taken from the 16th group. In the same way, second FEC block, for the second FEC block, the first byte is taken from the first group, and this will be the second byte. Second byte is placed here. Third byte is placed in the third FEC block. In the same way, the 15th byte is placed in the 15th FEC block of the first byte, and 16th byte is placed in the first position of the 16th FEC block. In the same way, the second byte you can see, third byte you can see, the third byte of each FEC block is taken from the third 16 byte group. In the same way, 15th byte of each FEC block is taken from the 15th 16 byte group. You can see here the first byte is 40491 and the last byte is 40641. 4065 here and 4080 is here. So this is all about the FEC formation, and each FEC block, the position of bytes taken from the either from the overhead, payload, or the FEC. Thank you.